Hi everybody, welcome back to this playlist about the mathematics behind AI. And in this video we're gonna take a look at the idea of what we call supervised machine learning. The ML stands for machine learning, of course. We're gonna take a look at an example. Assume we have data points. Of course, AI, machine learning always has to do with data. So assume we have some data points, and what does our data consist of? Of tuples. Tuples, x's and y's. For example, the x is the population of a city, the number of inhabitants, and the y is the average income of the inhabitants of a certain city. And let's say you collected for n of those. Maybe think n 100, for 100 cities you have this. So what you can do, since we're just working with an x and a y, so we're working in r squared, so in the plane, so we can easily draw this. And you're gonna draw these guys here, and what you notice, and that's often what AI tries to do, find patterns in certain data, and you can actually see what, this actually looks like a linear connection between the x and the y, because I can draw a line through these points. And so what is the idea of ML? What is the idea, or let's say rather the goal, is generalize this. What do I mean by generalize? Actually, we mean like look for a function f which goes, our data consists of tuples, which goes in this case from R to R, so which maps an x to f of x, such that this function f, the graph of this function, is very close to all of the data points that we collected, meaning such that for every I, so we have these n data points, so let's can even say for every I between 1 and n, if I evaluate this function f in my ith data point, this is almost or very near to the actual y value, y of I, of course. And this is why we are speaking of supervised machine learning, because we actually have what we call labeled data. We have n data points which actually have the label for the x value. For each of these n cities, we actually know what the average income is. So we have something to evaluate against. And because if we have this function f, we can evaluate in other points, because we're not going to collect this data for every city. Maybe we overlooked some cities with number of inhabitants which are a lot more, or maybe somewhere in between, and then we can just evaluate to make an educated guess, of course. Now, if we look at these data points, this is often what we see. Seems to be a linear connection, and linear lines in the plane, well, of course, polynomials of degree 1. So we are actually looking for, and remember this function, big function f from last video, from R to R, which maps m, q, and x to m times x plus q. Because we assume, based on what we see, well, a good candidate for such a function f can be a polynomial one of degree 1. So we need to find m and q such that we can actually make this f function such that, let me say f of x is big F of m and q and x. Because we know from last function, with every choice of tuple m and q, we get a line, get all these lines. So we're looking for the one that gives us the blue line. Question, of course, is how do we have to find this m and q? And that's what we're going to find out in the next videos. Ciao.